Hello everyone, in this video we are going to test whether the series 1 by n factorial converges or diverges. We are going to use two different tests, ratio test and comparison test, to test this series. So the time at which each of the tests starts is linked in the description box down below. Please subscribe to make sure your maths teacher never gets mad at you. Moving on with ratio test. Wait a minute, why ratio test? Well, the series 1 by n factorial has factorial in it. So whenever you have a series with factorial, your first choice should be ratio test. And if it fails, then use any other test. So let's see what's the definition of ratio test is. If an is a positive term series such that limit n approaches to infinity, an plus 1 divided by an is equal to the limit of the series an, then the series converges if L is greater than or equal to 0 but less than 1. The series diverges if L is greater than 1, and the test fails if n is equal to 1. So whenever we apply ratio test on series having factorial, by taking ratio of an plus 1 and an helps us eliminating most of the terms of factorial, making it easier for us to find the limit. Now let an equals to 1 by n factorial, which is our given series. Then an plus 1 is equal to 1 by n plus 1 factorial. Now for ratio test, we divide the term an plus 1 by an and then simplify it. Since n plus 1 factorial is equal to n plus 1 into n factorial, so we get this. Now this is the most simplified form of our series. So now we apply the limit n approaches to infinity on it. On applying limit on 1 by n plus 1, we get 1 by infinity, which is equal to 0. Hence, by the ratio test, the series 1 by n factorial converges because our limit is equal to 0. And the ratio test says that if the limit is equal to 0, the series converges. Now move on to the next test, which is the comparison test. If two positive term series an and bn and k is not equal to 0, a fixed positive real number independent of n, and there exists a positive integer m such that an is less than or equal to k into bn for all n greater than or equal to m. If the series bn converges, then the series an converges. And if the series an diverges, then the series bn diverges. You have to memorize these rules. And I know to memorize the rules of comparison test is a little challenging, like whether an converges and implies that bn diverges, or is it the other way around, because we have to memorize a lot of other tests as well. So I'm going to share with you how I used to remember it, but if you are not interested in that, you can jump to the actual application and the time is given in the description box down below. Okay, so think of a road and an and bn are two paths on that road, where an is smaller than bn as we have in the comparison test. Now each of these paths an and bn have a gate at its end. Now we call the blue gate as gate an and the green gate as gate bn. Now a car is coming on that road, and if the car reach at the end of the road, we have two short observations. If gate bn is open, then an must be open. And if gate an is closed, then how could the gate bn be opened? So bn is also closed if an is closed. But we can't get any information if bn is closed, because if bn is closed, then gate an could be opened. It is not necessary for bn to be opened in order to open the gate an. So we are not sure about the gate an. And also if an is open, we don't know if bn is open or not. So the key points here is converge is equal to open and diverge is equal to closed. So if you apply the comparison test rules on it, you can see if Bn is open or converged, then An is open or converged. And if An is closed or diverged, then Bn is closed or diverged. The short info. Let me know in the comments down below, do you like this technique to memorize stuff or not? So I can bring you more similar techniques, or just forget this whole idea. Now let's move towards the application of comparison test on the series 1 by n factorial. Alright, so you already know that a comparison test requires two series, and we have only one series which is 1 by n factorial, so we need another one to compare it with. To do so, we start off with examining the behavior of factorial with digit 2. Why we did that? Well, stick with me and I will explain it to you in the next slide. 2 factorial is equal to 2 raised to the power 1, but 3 factorial is not equal to 2 raised to the power 2, but it is greater than 2 raised to the power 2. So if we keep moving further, we can generalize that n factorial is greater than or equal to 2 raised to the power n minus 1, where n is greater than or equal to 2. So here we have established n factorial from our series 1 by n factorial. So let's move on to the next step. Guys, we need 1 by n factorial, right? So we take the reciprocal of this inequality to form 1 by n factorial. And the 1 in this step represents the k from the comparison test. Next, we let 1 by 2 raised to the power n minus 1 as our Bn, the series that we are going to compare with 1 by n factorial. So this implies that An is less than or equal to Bn, where An is 1 by n factorial. The Bn that we have created here is basically a geometric series with common ratio 1 by 2, which is less than 1. And the geometric series which has a common ratio less than 1 is always convergent. So our Bn is a convergent series. So now you can see why we compared the factorial with the digit 2, because we wanted to create a geometric series like that. So my friend, by comparison test, the series 1 by n factorial converges. That's it for this video. Let me know what other topics you want me to cover. Your opinion is always appreciated. Take care and bye bye.